Hey, smooth draw was bothering me, so we're using paint. Anyways, so if you want to know if a number is divisible by 7, well, I mean, obviously you can just divide by 7 and see if there's a remainder. So this would be 1, and this would be 4, and then that's remainder 2, right? And so that's not divisible by 7. But there is a trick to it as well. This is not a great example for the trick. Let's say 156. What you can do is you can take the tens and above, so in this case 15, and then you can subtract from it 2 times the last digit, which is, okay, so this is 12, and this is 3, and then 3, you see if it's divisible by 7. It's not, and so not divisible. Pretty simple, but why does it work? Well, this number here, 156, what you could represent this as 10 times m plus n. So in this case, m would be 15, and n would be 6. And you can represent any arbitrary length base 10 number this way, and the conversion is really simple. You just move the digit. Now what we want to know is we want to know if 10m plus n modulo 7 equals 0. And we are asserting that this is true if and only if m minus 2n modulo 7 equals 0. Sorry, I think in math you're supposed to just use one of those. I'm thinking in Python, but okay. So let's see if we can see why this works. So we have 10m plus n is congruent to 0 modulo 7, right? Now the first thing you want to notice is 10 is the same as 7 plus 3. You can add or subtract 7s arbitrarily as long as you're doing equivalence modulo 7. You can get rid of or add or subtract 7s as you see fit. That's fine. So we say it's equivalent to 0. We get rid of the 7, and we have 3m plus n is congruent to 0 modulo 7. Now, we would like to get the m by itself. We're just trying to get it into this form over here. So the modular inverse of 3 modulo 7 is 5. That's because 3 times 5 mod 7 equals 1. Because 3 times 5 is 15. That's 1 more than a multiple of 7. 1. Now, not everything has a modular inverse, but we're lucky that this one does. So, sorry, mouse slipped. Okay, so we can multiply this whole thing by 5. So we get 5m plus, or excuse me, 15m plus 5n is congruent to 0 modulo 7, and then obviously this is just 2 times 7 plus 1 times m, and anything multiplied by 7 congruent modulo 7 you can just get rid of. So this simplifies to m plus 5n is congruent to 0 modulo 7. Now we're almost there. Now this would work as a trick. You could do this. You could say, 15 plus 5 times 6, is that divisible by 7? And if it is, then that would be your answer. But probably easier to work with smaller numbers. So what we do is we just take away 7n. Now, that's the same as adding 0. So m plus 5 minus 7 n congruent 0 modulo 7, and this just becomes -2. like that. Okay. All right. See ya.